Okay, today we talked about a piecewise linear function. And a piecewise linear function is a function from the union of the intervals on the real number line that are defined by possibly different linear functions on each interval. What that means is something like this. We have a function. It passes that vertical line test that makes it a function. Every x maps to one y. And every input has one output. So what we have is we've got that red line and the blue line. And they're colored that way so that you can see that even though it's a function, it does have two separate components. So you notice that this red section of the line is a different linear function on that blue section, but they come together for one. We're taking the union of each section of that line. So what we were talking about today was stories with these piecewise linear functions, and what we want to discuss for tonight's homework is how to find the intervals where they are increasing, decreasing, or staying the same. So we can talk about the interval as going from -3 on the x to +1 on the x. So from -3 to +1, it is increasing. From +1 to +5, it is staying the same. There is no change. Now, this particular graph does not give us units or give us any kind of indication of what the story is, but a few things I wanted to point out. You'll notice at the bottom here, where I'm drawing the arrow, there is an open circle. That open circle denotes that the line doesn't actually touch that number. There's a little bit of a gap. So we'll learn more about interval notation, and we'll learn more about what those circles mean. But in this case, we can kind of see that the intervals go from -3 to 1 and from 1 to 5. So being able to spot where your line is changing is the important part. On the next example, we do have a little story. So as you can see on the x-axis, there is time in hours, and the y-axis is distance in miles. And that little motorcycle tells us that this is a story about motorcycles. So someone's obviously taking a bike ride, and at no hours, they haven't started yet, they have gone 0 miles. And by 1 hour, so in 1 hour, they have traveled 25 miles, meaning that they're going at a rate of 25 miles per hour. And from 1 to 2 hours, now they're going a little faster. They're going from 25 miles to 75 miles. So they have traveled 50 miles in 1 hour. So the first part, you're going 25 miles an hour. Then they're doubling it to 50 miles an hour. Then from hour 2 to 3, we have a flat line, meaning they didn't go anywhere. They didn't change. Their miles have stayed the same, so maybe they stopped for lunch. And from hours 3 to 5, where it's steadily increasing, they have gone from 75 miles to 125 miles, which is 50 miles in 2 hours. And if they have gone 50 miles in 2 hours, then they have gone 25 miles per hour. The same as the first hour of the trip. And I will show you how you can see that. So I'm going to highlight here. We notice that if we draw this line, okay, that line there is the same. It has the same slope, so it has the same rate. So they are going 25 miles per hour in both of those sections. In the section from 1 hour to 2 hours, you can see that they're going 50 miles per hour, they're a little steeper. Okay, the steeper it is, the more the y-axis is changing, in this case the miles. So they're getting more miles, it's changing, it's a little steeper, they're going faster. In the time from 2 to 3 hours, it's staying the same, there's no change, they are not moving. It has no slope.